Hi Year 9, today what we're looking at is finding an unknown side using tan, which is exercise 1204. So what you're required to do is questions 1a, c, e, g, i, questions 2 to 5, and questions 6, a, b, e, f, and questions 7. So for question 1, we want to find the value of a correct to one decimal place for each triangle. Now, as you are required to do A, C, E, G, I am going to talk you through how to do B, D, F, and H. So for question 1, it's important to note when finding an unknown side of tan that our tangent ratio is tan theta equals our opposite over adjacent. So to find the unknown side, what we do is we substitute into this ratio by first labeling our triangle of our hypotenuse, our adjacent side, and our opposite side in relation to the angle marked. So that's the first step that we're going to do. So opposite my right angle is my side that I call my hypotenuse. I'm going to put a H on there. Opposite my angle I have been given is my opposite side, and next to my angle that I have been given is my adjacent side. So what we want to use is we want to use our O and our A for our tangent ratio. So for our tangent ratio, we have tan theta equals our O over A. So we're going to substitute these in. So we'll have tan of our theta stands for our angle. So our angle here is 27 degrees. So we'll substitute that in. And our O is our unknown pronumeral A, and our adjacent side is worth 10. Now what we're doing is we're solving for A here. So what we want to do is we want to get rid of this denominator. So in order to get rid of this denominator, we are going to do the opposite of divide, which is times both sides by our denominator of 10. When we do this, we're left with our pronumeral of A equals 10 times tan 27 degrees. So what we're going to do is we're going to put this into our calculator. So we're going to go 10 times tan 27, close our bracket, equals, and when we put this into our calculator, we get that A equals 5.095 254495. Now, our question asked us to answer correct to one decimal place. So to one decimal place is this point here, or place here, but this 9 is greater than 5, so it's going to round the 0 up, be a 1. So A will equal 5.1 there. Now we're going to do exactly the same for part D. So part D, we have here, so we have been given our angle of 61. So our side opposite our right angle is our hypotenuse. Our side opposite our angle is our opposite side. And our side next to our angle is our adjacent side. So for tan, remember we want our opposite side and our adjacent side. So then what we have is we have our tan ratio. So we're going to write that out first. So tan theta equals O over A. Then we're going to substitute in our angle. So tan 61 degrees equals our opposite side, which is our pronumeral A, over our adjacent side of 9. Now, just like the last question, we want to get rid of the denominator of 9. So what we do is the opposite of divide, which is we times both sides by 9. So when we do this, we're left with A equals 9 times tan 61 degrees. So we put that into our calculator. So we go 9 times tan 61, close our bracket, hit equal, and we get that A equals 16.2364298. And again, we want to round this to one decimal place. So that is the 2. The 3 is less than 5, so it does not round the 2 up. So our answer will be 16.2. For part F, we want to do exactly the same as B and D. So what we do is we have our angle 49. Our side opposite our hypotenuse is our opposite our right angle is our hypotenuse. Our side opposite our angle is our opposite side, and our side next to our angle is our adjacent side. So then what we do is we write out our ratio. So our ratio is tan theta equals O over A. So we want our opposite side and our adjacent side in relation to our angles. So we're now going to substitute these in. So we have tan of our angle of 49 degrees equals our opposite side, which is worth our pronumeral of A, and our adjacent side, which is worth our pronumeral of 20. So then what we're going to do is we want our A by itself, so we want to do the opposite of divide by 20, which is times by 20. So we multiply both sides by 20, and we're left with A equals 20 times tan 49 degrees. We then put this in our calculator, so we go 20 times tan 49, close our bracket, equals, and we get 23.00736,814. Again, we want this to one decimal place, so our number after our decimal place is 0, the number after that is 0, so it does not round it up, so A will equal 23.0 to one decimal place. Now we're going to look at question 1H. So question 1H, I'll just quickly rub that out. What we have is we've been given our angle 60 degrees 20. So our side opposite our right angle is our hypotenuse. So we label our hypotenuse. We then label our side that is opposite our angle, and then we label our side which is next to our angle, which is our adjacent side. So with our tan ratio, I'm going to write that at the top here. So we have tan theta equals our opposite side over our adjacent side. So what we have is we'll have tan theta equals O over A. We're then going to substitute in our angle and our opposite side and our adjacent side. So our opposite side and our adjacent side. So we have tan 60 degrees 20 minutes equals our opposite side of A over our adjacent side of 12.6. I'm just going to move this up one because I don't think I left myself enough space otherwise, and fix up my tan, sorry. Okay, so now what we want to do is we want to get rid of our divide by 12.6 over here. So exactly like the last three questions, what we do is we do the opposite of divide, which is times both sides by 12.6. We then have A equals 12.6 times tan 60 degrees 20 minutes. Now what we have to do here is we have to put this into our calculator. So to put this into our calculator, we go our 12.6 times tan 60, and then we hit our degrees, minutes, seconds button before our 20, and then our degrees, minutes, seconds button, and then our bracket and our equal sign. So we're going to go 12.6 times tan 60 degrees, minute, second button, 20 degrees, minute, second button, close our bracket, equal sign, and we get A equals 22.12004357. And so again, we are rounding this to one decimal place, so it will be 22.1. Now, question 2, we have a worded question with a diagram. It says a ladder leans against a wall so that the angle it makes with the ground is 52 degrees. Its base is 4 meters from the wall. How far does the ladder reach up the wall? Give your answer correct to the nearest centimeter. So what we want to do here is we want to work out what the question is asking us. So it has given us some key information. It has told us that it makes the ladder leans against the wall, so it makes an angle with the ground is 52 degrees. So that has been given to us on our diagram. Its base is 4 meters from the wall, and then it asks us how far does the ladder reach up the wall. So what we're trying to find is how far does the ladder reach up the wall. So we're trying to find this distance here. So I'm going to call this distance H. And that is what we are trying to find. We are trying to find H. So what I'm going to do is I'm going to draw a triangle to represent this drawing that has been given to us. So we're going to draw a triangle, we're going to make sure it's a right angle, and we're going to label everything that is on our diagram over here on our drawing that we are creating. So we have our 4 meters, we have our 52 degrees, and we have our h meters, which is our unknown side. What we're then going to do is we're going to label our triangle with our H, O, and A. So our hypotenuse is opposite our right angle, our opposite side is opposite our angle, where our angle is 52 degrees. So it's opposite our angle, which is going to be H. And then we have our adjacent side, which is next to our angle, which is 4. So remember, with tan, we'll have tan theta equals O over A. So we now want to substitute in our angle and our opposite side and our adjacent side. So we'll have tan 52 degrees equals our O of H over our A of 4. We want to get rid of this denominator of 4. So we do the opposite of divide, which is times by 4, because we're trying to find the value of H. So what we're left with is H equals 4 times tan 52 degrees. We put that into our calculator. So 4 times, we don't write it out, we put it into our calculator. So 4 times tan 52 degrees equals 5.119766. 529. We then need to check back with our question. It asks us what units it wants us to answer it to, and it says give your answer correct to the nearest centimetre. So our nearest centimetre is just 5, so H will equal 5 centimetres. Moving on to question 3, it says find the length of a rectangle if the diagonal makes an angle of 62 degrees with the breadth, which is 6.3 centimetres. So we've been asked to find the length of a rectangle. So we're asked find the length of a rectangle. So the length of a rectangle is this distance here. So that's what our unknown is, and I'm going to call that unknown X. And then we have been given the angle of 62 degrees, which is here, and we have also been given its breadth, which is 6.3 centimetres. What I'm first going to do is I'm going to draw this triangle out like so, and label everything that is on the diagram on my drawing. So we have this is X, this is a right angle, this is 62 degrees, and this is 6.3 centimetres. So we have been given our angle of 62 degrees, and then we want to label our sides. So our side that is our hypotenuse is opposite our right angle. We have our opposite side is opposite our angle, and we have our adjacent side is next to our angle. So we are using tan here, remember? So we want to use that tan theta equals O over A. So we'll substitute in our angle, so tan 62 degrees, substitute in our opposite side of X over our adjacent side of 6.3. We then want to multiply both sides by 6.3, and we're left with X equals 6.3 times tan 62 degrees. So X equals 6.3 times tan 62. Into our calculator, we get 11.84857673. So X will equal, give your answer correct to one decimal place. So it will equal 11.8, as this 4 does not round the 8 up. Question 4, we have how high is this flagpole to the nearest centimetre if a supporting wire from the top makes an angle of 59 degrees with the ground, and the wire meets the ground 37 metres from the base of the flagpole, like so. So what we have asked to find is how high is the flagpole. So we want to know this height here. Generally, when we're finding a height, we label that H. So I'm not going to complete this question for you. I have done the last 2 worded questions, so I want you to have a go at this one yourself. So draw this as a diagram, label your sides, substitute in your values into tan theta equals O over A, and solve for H. For question 5, we have find the height of this isosceles triangle. It has a base of 16 centimeters and base angles of 61 degrees. So what we want to do with our isosceles triangle is we have been asked to find the height. So we actually want to break our triangle in half when we draw it out as our diagram. So I'm going to start this one off for you as it is a bit of a tricky question. So we're going to break our isosceles in half and we just want to look at this side. So we know that this is 61 degrees, it is a right angle, and we are trying to find our H here, our unknown. What we need to work out is how long this part of our triangle is. So our isosceles triangle has a base and it's been split in half exactly. So that means that this is the same length as this. So if the whole length is 16, it means that both of these lengths here have to be 8 centimeters. Now that I have helped you draw the drawing, you should be able to label your triangle, substitute these values into tan theta equals O over A, and then solve for H.